Okay, hello guys. I'm glad to see you here. Sorry for your waiting. Actually, we should start because I don't want to tell you a lot of different words that I'm glad to see you here because you know that it is so. Let me just announce pretty important information at the start of this meeting. That actually it's not only one meeting. We prepared for you series of this meeting from Java practice, and this is only the first one. Please watch it. Please wait like second one, third one, because we prepared a lot of useful information, different speakers, different themes, but all of them are related to Java. And okay, for now, let me just start show you what are we going to talk about today. And we will be talking about Java's Blackjack. Why did I choose this theme, like Blackjack? Because it's, first of all, it's pretty popular game in US, in America, and the main idea of this game is to have on your hands 21 points, like pretty complicated rules, maybe not so complicated, but you know, for Slavic countries, we have like pretty same game. It calls 21 or Achko, but anyway, like rules are pretty same. And yeah, it's a winning amount of points, and that's why we have Java 21, which was released half year ago, and it is LTS version. And this version, I hope that in case if you don't use it for now in production, you will use it, I hope, this year. Okie dokie. And let's get started. Let me start. Oh, sorry, guys. I can see here, not maybe right. Okay, let me maybe change it a little bit. We won't see any animation, but it seems that my screen is presented on another one. Let me just close this tab bar. No? Okay, I tried. Okay, guys, let's get started. And the first slide, let me introduce myself. My name is Nikolai Ischenko, and I've been working in Coherent solution and for eSoft company. eSoft, it's a part of Coherent solution. I work here as a department manager, dev lead, because I still like put my hands into the code, and together with it, I like to work with people because I love them, you know that. And in IT sphere, I've been working for a little bit more than 16 years with Java in Java world. I've been working for 10 years, a little bit more as well. And in my free time, I'm crazy developer. What does it mean? I usually do some synergy between coding and between hardware. As you as you may know, before we developed together some vending machine for eSoft, which gives you chewing gum for your smile in case of you are smiled, and in case of you took photo, and on this photo we recognize smile on your face, you will receive chewing gum, but just only one per day. And I'm also speaker. I was a speaker on different platforms in different countries, and as you can see on this screen, like the most, I can't say that the most popular, but one of the popular video on YouTube about new features in Java 17. It was recorded by Nikolai Ischenko, and as you can see, he's on the right side on this screen, and he provided me this information about new features. And Eugen Borisov, with his chair, shared with me some new features related to Java 17, to Java 21, related to Spring. Okay, and let's move further. What actually does it mean, LTS? It means a long time supported version. And we have long time supported version that is provided by different vendors. First of all, for sure, it's still Oracle. And Java belongs to Oracle, first of all. However, together with it, we have another bundle, OpenJDK bundle. And this bundle can be produced, I would say, by different vendors: Red Hat, Bellsoft, Zulu, and so on and so forth. For sure, Amazon, Microsoft was in this list. I'm not sure about current situation. And yeah, IntelliJ IDEA was updated, and in case if you click on your keys Control Alt Shift S together at the same time, you will see your project settings. And before, if you open this combo box, you will see whole of the list with available versions. For now, it was updated, and for now, it is split into two blocks. Block with LTS versions, and I've done a screenshot here on your screen. You can see it with versions 8, 11, 17, and 21. And we will be talking a little agenda about this meeting. We will be talking first of all about new but actually old features from Java 17. And after it, we will be talking about new and really new features from Java 21. You can tell me, hey Nick, what about Java 22? Yeah, this is the version that was released maybe a month ago, as I remember. However, it's not LTS version, and I'm not sure that this version will be used on real production, because production usually prefers long-time supported versions. And I will tell you why in the middle of this presentation. Okay, let's go further. Let me try to do it. I'm not sure that it will be okay, but I hope that you can see my screen. At minimum, like at the middle of the screen, you will see this slide. I just want to show you this animation. I hope that you can see it like without any borders around it. I don't know. Let me maybe check it. Okay. Oh, that's even better. Okay, why do we use Java 17 for now? Because Java 11 isn't supported yet. This period, when it was supported, it was ended in September 2K23. Again, you can tell me, hey Nick, what about like other vendors? Because this date is relevant for Oracle. Yes, sure. For Red Hat, for example, for OpenJDK bundle, and in case of OpenJDK bundle that is provided by Red Hat, this bundle is supported till October, but anyway, this year, that's important. And Oracle has, for now, some additional item in the document about this release, about releases, about this period where different versions will be supported. And in this document, you can find like a little additional item that for the Oracle's clients, it will be extended till 2K something in the future. But just make this quest, just try to be Oracle's client. That's a great and pretty complicated quest, but pretty cheap actually. Sorry, pretty cheap, pretty expensive. And what about another reasons for using Java 17 even today? Actually, the main reason is like using Java 21, but let's talk about 17 first of all. Spring Boot 3 and Spring Boot Framework, Spring Boot 6, which we have under the hood of Spring Boot 3. It requires it. It is required in case of this version of Spring, because this version was built at the top of the new Java's features. And yeah, in case if you want to use new Spring, new features, stable and version without any vulnerabilities, you have to move to a new version of Java. Okay, what else? Before in Spring, sorry, Eugene. Before, in case of Java 11, Oracle has not really obvious rules in what kind of cases Oracle requires to pay money for Java 11 bundle. And it was like pretty like a few common phrases that were published, and according to these phrases about these rules, it was not really obvious that these versions can be used for free. And that's why in Java 17 these rules were rewritten, and for now Oracle no fee terms and conditions is available, and you can read it on the internet. It's another version, and please just do it. And yeah, for sure, new and old features, we will be talking about them during the first part of this presentation. But guys, what do I want to share with you? This is this part of presentation. During my preparation for that, when I tried to gather all of the information through the internet, I save like all of the links and useful information here at the bottom of this presentation. And it will be available for you directly after it. And together with it, for you will be available code repository. I will show you a lot of the examples within this presentation with new features. However, in general, after all of my slides, you will see 2 slides with QR codes, and if you follow these QR codes, you can find GitHub repo with these examples and some additional information. But anyway, during this meetup, I hope that you will hear a lot of useful information. However, directly after it, you will be able to try them by your own hands. Okay, let's come back to our slides. Yeah, as you can see, almost each of the slides, these slides have this useful information. Where's my mouse? Let's get started. The first feature, text blocks. This is syntax sugar that can be used in case if you cover your application with testing pyramid. In case if you have to write unit test, integration, component test, and end test, you have to put some input information for your controllers, for your endpoints. And before we used to use separate files with some XML information, with some JSON information, and them like are not connected directly with the code. Yes, we can and we could use direct injections into the code, but together with these injections, we had to use like special symbols with using slash, and still I don't remember half of them. I just remember slash n maybe to start from the new line. However, these special symbols, you have to use it, or you have to write down all of the raw JSON or XML, doesn't matter, in one line in case if it's like pretty simple one, or you have to put it to a new line and so on and so forth, and it's not obvious to read. Instead of it, for now, you can use text blocks, and it's useful, especially when you write your tests. This is the first feature. Once again, I will show you some examples how can you do that and how it can be useful in real code. However, this is like pretty tiny feature. This is syntax is sugar, but let me show you how you can navigate in this project that you can find on GitHub. In this project, on the main branch, you will find readme.md file, and in this readme.md file, you will find this information that is described with using text, with using some examples, and also you are able to move to another branch directly from this readme file. Nope. And here on another branch, you will find some pieces of the code, you will find some tests, and you can find how it can be used. I don't want to start it, I just want to save your time because it's pretty tiny feature. Let's come back on our slides and let's proceed with other features. Okay, pattern matching for switch. This is like what this is the question that I had when I start learning programming. I saw that, like, why do we have to use a break at the end of each of the line? Because I haven't ever met any situation when I really when it can be really useful to move from one line to another line, and after that to another line, and only after it to meet break and stop making this switch. That's why it wasn't my thoughts only. I hope that developers and contributors to OpenJDK also had the same thoughts when this feature was introduced. Yes, first of all, for now we don't need to use this additional special word at the end of your line within your switch case construction. However, together with it, we have some additional rules, I would say, that we have to follow this row, like that you can find, and the same row that you can see when you make your lambdas, and special word default, where you can describe default action in case if no one from these from all of these cases work. No one work. Yes, right. In this case, default will be working. Okay, let's go further. Records. And yes, in case of pattern matching, please open this code. Please open this branch and take a look at the example. It's really easy example that's why I don't want to open it and stop this presentation to show it to you. However, about records, this is the feature that I want to show you on the code. Why? Because records, I would say this is the feature that I hope anybody know for now. However, it's not really useful feature, and I will try to describe you why. We tried to use it together with our clients, but actually for now we don't use it on production. And the reason why we don't use it is Lombok. Why it is so? Let's see. Oh yeah, sorry, this is a spoiler. Yeah, actually Lombok wins. Before we dive deeper into all of the examples, all of the examples are related to Blackjack game, or like Uno game, some card game. But as you remember, Blackjack, this is a red line through our current presentation, through our current workshop, I would say. That's why you will see only all of the examples that are related to this theme. And here we have deck of cards record, where and this record has three properties: number of cards, has logo, and brand. Does it look good? I would say in general, yes. Okay, we can. Here we have an ability to create an instance of this record, and it will be created by using constructor. We don't write it here, but it is generated automatically, as well as toString, hashcode, and equals methods. They will be generated. And as I mentioned before, it works okay. However, look at this example. In case if we have like more than 3 properties, for example, we have 1, 2, 3, 4, 5, 6. How does it look like? I'm not sure that it looks good, because you have to scroll on the right side, first of all. After it, you have to remember all of them. You have to remember order of these properties. And here you can read names of them. However, during the implementation, IntelliJ IDEA doesn't suggest you to use Like for example, in this certain place, you have to use some value for haslog. For this one, you have to use some value for the color, and so on and so forth. And together with it, let's look at this example. When we use, for example, the same structure with the same amount of properties, but together with Lombok, you can put at the top of that two annotations, builder and value, and with these two annotations, you can use and you can build your instance in a random manner, and together with it, it will be like still immutable. Okay. Yeah, that's why we, for now, I would say we don't use records, because it's not really good pattern to use and to create instances using record, using constructor, and put inside of this constructor 6 or even more than 6 properties. I think that it's pretty basic rule for each of us. Okay, that's why Lombok here wins. And what do we have else? Pattern matching for instance of. Unfortunately, I don't put here an example like directly. I don't inject it, didn't inject it into this slide. However, it's also pretty easy example to look at, and together with it, sealed classes, and or I named them final with some exceptions. Let's look at two of these features on the code. The first one will be pretty easy one, but it's important to look at that because it will be related to other features that will be introduced, and they in Java 21, and they were already introduced. Let's move back to our main branch. Main. Okay. Where is our documentation? I use it because I want to show you how you can do it at home, at work maybe. Pattern matching for instance of. How I can zoom it? It seems that I have no. Oh, zoom maybe. Nope. Not compact mode. Okay. In this case, guys, I don't want to spend your time. Let's just move to appropriate branch, and I will show you. Okay, maybe it will be faster in case if I just jump into this branch with pattern matching. I will show you what does it mean, and we will go further to sealed classes. Okay, what did we have before Java 17? In case if we build the same instance of this class, of this class, we can build it, and after it we when we try to understand what kind of object do we have here, we usually write obj instance of and check whether this class in front of us or no, and directly after that on the line number 20 we have to use this construction to use this object and this instance as like certain instance deck of card value. And it was before. It's additional step that isn't required for now. What can we use for now? We can use this construction. And as you can see, after Java 17, we can write directly here obj instance of deck of card value and name of your variable. And deck of card value can be used here as an instance, as a certain instance, not just a general object. Okay, and let's step back to our main branch. Git stash git check out main. And we are here. We will open sealed features. And we will move. We will move to our tests related to sealed classes. Okay, and here I have to move back from our tests to maybe to the implementation. And let's imagine in what kind of cases it can be used, and it can be useful, first of all. It will be especially useful in case if we develop our own module, and this module will be used like outside, somewhere outside. For example, we can create some framework or library or just some piece of our implementation that is commonly injected or used as a dependency in other places. And in this case, we want to stop this ability to use our classes and to extend our classes with some additional functionality. Before, we could do that with using final word. However, for now, and it wasn't really convenient because with using this final word, you don't have any ability to extend the same class in some other places within your framework, within your library, within your module. However, now with using sealed, this special and reserved keyword, we have this ability. How can we use it? We can write directly here that this is like public, abstract, and sealed. Abstract, it's not required, but in this example, we have it. Public, abstract, sealed class card, which permits playing card and Uno card extend this abstract class. And in case if we move to playing card, here we can use our final word, we can use it. And here we will be able to extend our abstract card, abstract class that was described before. And the same situation for Uno card. And let's do a few steps back. And yeah, here, as you can see, we are able to create only two instances, like one of the example for our playing card, one of the example for our Uno card, and here we are able to check that these classes has some certain actually classes under the hood. Okay. Yeah, and this is example. This is like another example which combines inside of it this theme sealed classes and previous one pattern matching, for instance of. That's why, yeah, in case of you're interested in some certain theme, in some certain feature, please anyway move through all of the branches. Take a look at these tests, take a look at this functionality, because for now it's like only some functionality from Java 17. After it will be more interesting. We will move and we will dive deeper, and actually we will simulate our Blackjack game, and I will try to show you how can we do that. And that's it about our first part, where I wanted to share Java 17's features, and maybe features as you want. For now, we are going to talk with you about new LTS version of Java, Java 21. Once again, as you can see on your screens, under each of the slide, I hope under each of them, you will see like useful links. And on this page, for example, you can find all of the JEPs that were released between Java 21 and Java 17. What does it mean, JEP? Java Enhancement Proposal. Because for now we have like new features that are introduced in new versions, and these features, first of all, can be discussed, can be proposed, can be implemented. After it, they should be tested, discussed again, and so on and so forth. And we can see them in the versions in between LTS versions. It can be tests on our real projects, but I actually don't recommend to use and to test them on production, because some of them can be tested with using some additional flags when you start your Java application. But as you want, guys, and just let me show you that this Java version, Java 21, was released in 2K23. It was in September. And let's start with the most complicated feature from this version of Java. Java virtual threads. Okay, what is it? I will try to show you what is it, but before I do that, let's imagine let's try to remember what kind of interaction did we have before, and do we still have. First of all, it is synchronized approach, a synchronized way of making our tasks in different threads. And what can I tell you about synchronized one? Let's imagine that we have tables where players want to play our blackjack game, and players, one step back, players are sitting like in front of this table, and they are waiting for dealers. And let's imagine that player and this playing game, it's some kind of task, and our dealers, it's their threads from our real operating system. And in synchronized approach, we can ask, okay, we have 1, 2, 3, 4, 5 different tables, 5 different tasks. We want to play 5 games, and we can ask our operating system, we can ask our casino to provide us 5 dealers. And when these games are ended, that's it. Okay, but that's important, that we will ask for 5 games, 5 dealers. For 5 games, for 5 tasks, we will ask 5 threads from operating system. Synchronized with pool. What is the difference between them? For this approach, we have 5 games, but we think that, okay, it's not optimal. In case if we ask for 5 dealers, it's pretty long period of time till our dealers will move from our casino, from our operation system, till our real gaming table. And we think, okay, we can ask for 2 dealers for 2 threads from operating system, and these dealers will move from table to table. But what is the important thing here? That dealer will be moved from one table to another one when game is ended. And this is most important thing within this synchronized with pool. Once again, that's it. A synchronized approach. We are not talking about virtual threads. We don't discuss with you Project Loom. This is approaches that we used before. Asynchronized. The same situation, however, we ask for 1 dealer, and this dealer will be playing a lot of games. For example, this dealer can make a turn and move from this table to another one until this task and this player is thinking about the next turn. For not to wait together with a player, dealer can move from one table to another one, from another one to another one, and so on and so forth. And after it, he can and he should return to the first table to finish this game. But in this case, we don't need to wait for the next step, for the next turn, in front of this table. We can run between them. Okay, and actually, before I heard a lot of different holy wars between different approaches about synchronized and asynchronized approaches, and I heard different items that were discussed between them, between these two approaches, between these two sides of like the same, I would say, interaction, but with some differences. That synchronized approach, programmers know better than a synchronized one, because it's another part, it's another, I would say, schema of interaction, and that's why we have a like for synchronized and dislike for asynchronized one. Okay, about synchronized, it spends resources on working with OS threads. That's true, unfortunately. When we ask for a new dealer, when we ask our operation system to provide us a new thread, it takes time. It takes time while this dealer goes from the casino to your table. After it, when this dealer starts this game, understands like context and so on and so forth, this is a process that which is really heavy, and it takes time. Heavy, I just let me share with you. I don't mean that it is heavy and it takes like few seconds, for example. No, it's like pretty fast, nanoseconds, maybe milliseconds. But anyway, when you have, for example, 1,000 thousands of thousands threads, you will calculate this time for sure. Okay, and another one item that asynchronized approach utilizes more computing resources as well. Yeah, from the previous item, I think this is like pretty obvious one, and yes, because we don't need to wait this time, and instead of waiting, we can do some useful calculations, computations, and so on and so forth. And easy to debug and profile, and it seems that in this case we can provide like for synchronized still and dislike for asynchronized, because yeah, it's like approach that we know. This is like pretty obvious approach because we are still in the same thread. We have like the whole of the context of our variables, and if we want to wait in this thread, we will be waiting, and we will spend our time, we will spend during debugging, but we will be in the same one. And for profiling, yeah, the same stuff. It's like more complicated exercise in case of asynchronized approach. And finally, we have 2 points for synchronized, 2 points for asynchronized. However, here on the screen we can see Project Loom, and Project Loom offers us that all of these items will be only pluses for Project Loom, for our virtual threads. What is the difference? Let's come back to our casino. Let's play the same 5 games, and let me show you what are we going to receive with using Project Loom. Do you remember this situation? This is the same situation that we had before with using asynchronous approach. And why do we have it? Before I move under the hood of Project Loom of virtual threads, let me first of all show you some code examples. Okay, we are here. Project Loom, virtual threads. Okay. We will move to appropriate branch. Okay, guys, let's dive into this code. Let's see what do we have here. This is the traditional approach, I would say, when we have amount of threads and when we have amount of threads equals to amount of tasks for this certain example. And when we have to run 10,000 tasks in parallel, we can ask for 10,000 threads. I don't want to run it for now because highly likely I will have like out of memory or something like that. It's pretty strange error that I received before. But anyway, operation system tells me that it has no any available threads for me. However, for your own hardware, this amount of time that you will spend till this moment, it can be different because you can have like more powerful hardware. That's why you can just, in case if you will not receive the same error, just add some zeros into and to this variable. However, let me just do this mapping. I hope that you remember this situation when we had 5 tables and we had 5 dealers. Okay. Another one situation, fixed thread pool with using like synchronous approach. This is like better situation because we don't need 10,000 threads for our tasks. However, we can ask 6 threads. Why do we ask 6 threads? As I could read before, the optimal amount of threads you can calculate by the next formula. In case of your computer has 4 and processor of your computer has 4 cores, you have to calculate and you have to multiply this amount to 1.5, and you will receive like optimal number of your virtual threads. But it's like, don't believe me, please try it on your hardware and please run this example and you will calculate your optimal number for that. But still, this is like a well-known approach for us, where we have executors, and when we ask from this class, okay, executors, could you please give us 6 threads from operating system, and we will be operating with them because we have 10,000 tasks, and we will give like one task for one thread, another one for another one, and so on and so forth. And when this one, the first one, will be done, okay, we will give another one task for operating system thread. And for doing this work, it works operating system scheduler. And this is also important information because with Project Loom, we have one additional scheduler. And when we come back to our slides, I will show you what is the difference and how does it work, this additional Java scheduler. And okay, let's scroll down to our Project Loom. Here we are. What do we do here? We are using the same class. As you can see, we use the same class executors. We ask like new construction, new virtual thread pair task executor, and we don't use anything here. Why? Because Java with this new scheduler can understand what is the optimal number of virtual threads or of our operating system threads. We don't need to calculate anything on the paper with using some of the information from the internet or try to run it on your local to get optimal number of these operating system threads. Just run it and it will be working. And about what do we try to do here? What kind of tasks do we have? Here we are playing real blackjack game. It is a simulation of this game, and in case if you start it on your local machine, in case if you start to let's start it. That's a good time to do this, but let's do that with only 10 different games because I don't want to make you waiting, just to show you this fun. Yes, and as you can see here, within each of the table we can emulate this game. However, here we have some kind of mess, because all of these tasks work in parallel. That's why each of them tries to put its own information into like common console. Maybe it would be better to mark somehow these different threads with some numbers, and you can review this code, and you can provide your proposal, and you can make this pull request to make this code better. Okay, guys, and let's come back to our slides. As I mentioned before, for now, we have these two areas. Here we have virtual threads, and we have our operating system threads. With using this construction, our project loom, or our okay, let's call it our project loom, can ask about 3 operating system threads to run all of our tasks, to run all of our stuff that we put into our virtual threads, instead of put it directly into operation system threads, instead of put this work directly there. Here on this area, in the area of virtual threads, we have to choose the right thread, we have to operate them somehow, and as you could hear before, for now Java has its own scheduler. And this scheduler can and should choose the right virtual thread that will be running for now. It can be some kind of mess, it can be some kind of heap, but actually it doesn't work in case of Java, because you have to synchronize all of this work, and it also takes some time. Instead of using this mess, okay, we can think about some common queue. And what can we do with it? Our 3 operating system threads can be working with 3 virtual threads to make some work. And for example, when we call with using network some external endpoint, and until we are waiting some of the response from the external endpoint, we can put this task to the end of the queue, and we can get from the start of this queue another task. But it also it can work, but it doesn't work in optimal way. We can do even better. We can split all of this work into like different queues. We can split all of them into 3 queues, 1 queue per operating system thread. And oh yeah, sorry, one step back. And yeah, operating system thread and our Java scheduler can work with and can provide this task for our operating system queue when this task and when this virtual thread is waiting something from the network, can be provided, and it can be put into the to the end of this queue, and instead of that will be restored context for the next task. However, this third operating system thread and our Java scheduler with our operating system scheduler can work with this third. Actually, our operating system scheduler should be working actually with all of these 3 threads in an ideal situation. However, let's see in case if we make all of the job for this third thread. We don't have any work for it. What does it mean? That this thread will be waiting for something. And it's not optimal, actually. We don't need to waste our time for waiting from the network, from like some other task. And instead of that, Java scheduler will provide additional work for this third thread. And this work will be split between 3 of them. Okay, another situation. The first one thread and the second one, they have a pretty heavy computation task for computation, and they are waiting, they are calculating something. And we still have three operational system threads. In case when we have to wait for some time for some kind of calculation, for not to wait too long to provide other tasks and ability to run other tasks in additional thread, Java scheduler can ask about additional operating system thread to make this work. And this work will be stolen from the thread number 1 and from the thread number 2, because it is Java. Java understands well that we have to make some kind of work. What kind of work what kind of work we are doing right now, because it's bytecode. Java can read itself and understand that, okay, here we have to wait. For example, we use thread sleep, and we have to wait for some period of time. For not to be waiting any response from the database, for not to be waiting just because, for not to wait any response from the network, we can just ask operating system about new thread and run this work into and within this the first thread. Okay, yeah, and okay, Eugen Borisov, and you can ask me the third time, as I remember, within this meetup. Hey, Nick, what and how can we use it when we return back to our projects? When tomorrow we will be working with our production, how can we use it and why it can be useful for us? In case if you use Spring, since Spring, let me check number of this version, Spring Boot 3.2, you are able to do that. And before, in previous version of Spring, you were able to do that, but with some additional beans, with creating some additional beans, with doing some additional work. However, since this version 3.2, you can turn it on with using only one property, spring.threads.virtual.enabled equals true. And for your Spring application, and your Spring application will be using these virtual threads for all of your flow of requests and data that your Spring application will receive as input data, and just use it, just turn it on, and yeah, just try it. Okay, as you remember, before with Java 17, we had records feature, we had pattern matching feature. For now, we want to combine them and we want to use record patterns. How can we do that? Let's come back to our code. Okay, once again, git stash. Так. Oh, sorry. Record patterns. Let's move to them. And record patterns. Record patterns before Java 21 look like that. Here, what do we have here? Here we have, for example, player hand. And within this player hand, this is a record. And within this record, we have two instances of other records. We have, actually interfaces. Yeah, two instances of card interface. And we have player hand first card, player hand second card. And we can create these instances with using playing card 1, playing card 2. And here, before Java 21, what do we need to do with this instance? If this instance was called as just object, we have to understand that this instance actually a player hand instance, and with using pattern matching we could do that. And after that, on the next row, on the next line, we can use instance of reserved word to manipulate with this property of this instance of the playing card of the player hand instance. And yeah, this is like pretty easy example. However, here we have to use 2 lines of code, and for now we have like another one, syntax sugar, and with this syntax sugar we can provide this example where we can understand that this player hand player hand instance is instance of player hand. Sorry for this blah 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 blah, but this is so. And inside of it we have player card number 1, and we can provide like this instance of inside of it, and directly after this line we can like just archive these 2 lines into one, and we can use these properties C1 and C2 directly on the line number 2, 3, and 4 without any additional steps in the middle in between of them. Okay, let's move on the next slide, because on the next slide you will see pattern matching, another one feature for pattern matching for switch. And I hope, yeah, this pattern here is clear. We can go further without any waiting, but no, it seems no, because a lot of code, and it's hard to imagine what's going on. That's why let me move back on the code, guys, and when I do that, you have an ability to think about your questions. You can put them on the chat, or you can write them down on the paper. Feel free to ask me at the end of this session. I prepared for you a special slide for that. Okie dokie. What do we have here? Let me try to remember, what do we have here? Pattern matching for switch patterns. Yes, switch patterns. Where do we have this code? Maybe inside of the implementation, not. Yes, sure. Yes, here we are. Okay, in this method, what do we need to do in this method? Let's imagine that we have some player hand cards, and we want to calculate amount of points in his or her hand. For doing that, we need to run this with using Java stream, for example, run this for each and go through all of these cards by one and calculate and understand what kind of card this player has in his or her hand. And for doing that, we have to call this method card value, and just look at this switch. It's this is a crazy switch. Please don't do it, first of all, on your production code. However, look at that. What can we do here? We remember that this card has and it's sealed class that has some permits for Uno card and playing card. And actually we are able to calculate, and doesn't matter what kind of card, we can calculate each set with Uno card or with playing cards. How can we do that? First of all, we receive some card, and we have some card in our hand, and we want to understand whether it's Uno card or whether it's playing card. And as you can see here, we have some 2 rows of calculation for Uno and 3 rows, I would say, in summary, for playing card. And don't do it in your production, because I would say that I would prefer maybe to split the switch between them, but I just want to show you how switch can be powerful for now. Because here you can write different conditions. You can write a condition to understand what kind of instance of do you receive in your hand, in your method. And after that, you can write some another condition, like whether it's integer or when ace equals to some certain value or even set of, and so on and so forth. Guys, as you can see, for now we can use a switch with like real great power. And what did we see before? What did we see here within this example? This is like another construction, generic construction, and we can use generics for records. And we can write down card pair, and this card pair can accept only instances that extend card instance. And within this card pair, we can have like two cards, card number first, card number second. And when we want to calculate amount of pairs, amount of points in our hand, we can just accept this card pair instance, and here in switch we can use this power that we were talking on the previous slide. Because here we can mention that, okay, we have card pair, but in case of like inside of this card pair we have two instances of playing card, please work with them and please log them as playing cards. In case of we have two UNO cards within this card pair, please work with them like with and calculate them like as UNO cards. And even we can play our blackjack game with using two decks, with using UNO card, with using playing card. We can match them and we can play them and calculate amount of points for both of them with using this branch of your switch. And still, this is a switch. That's important, and that's imagine. That's incredible. Okay, we have the next feature. Sequenced collections. And I draw here some kind of hierarchy of different collections, sets, lists, queue, the queue, and so on, and their relationship between each other. And what do we have here? We have on the top of them we have collection and different extension from this basic construction. And just I'm trying to describe it to spend some time for you to have an ability to understand where do we have this hierarchy, what kind of relations do we have between all of these items. And let me click on the space button, and yes, this is new constructions in the middle, which are called a sequenced collection, sequenced set, and another one because it's like another one tree, little tree, but anyway, tree with map, with sequenced map, and sequenced map for now in the middle, and all of other sorted map, navigable. Sorry, no, I'm talking with you more than 1 hour. Let me do another trying. Navigable map. Excellent. Linked hash map. For now, they extend sequenced map as well. Why do we need to use it? Let me show you the problem, initial problem of that. And let me tell you that we have just a few slides ahead. Be with us, stay connected. No? Maybe stash once again. Whew. Okay. And here we are. Virtual threads. pattern matching. Okay, sequenced collection. Let's move to directly to the example. Oh, however, I could show you on this readme.md, but okay, it's too late. Okay, what kind of problem did we have before with Java 17? We had different, and we still have different data structures like list, dequeue, sorted set, linked hash set, and what do we need to do if we want, for example, to get the first element from all of these data structures? Okay, let's play this game. In case if we want to receive playing cards from the list, we know because we work with lists every day, and in this case we have to write list collection dot get and get the first element from the list with number 0, because list starts with 0 indexing on, within the list. Okay, for list we can receive it. Let's do it. Let's do the same exercise in case of card dequeue. It looks even better because we don't need to remember any kind of construction. We can just use dot get first. That's it. Looks good. But for example, for set, sorted set collection, we have to use not get first, but first. And oh my gosh, why do I need to remember so much different approaches? But okie dokie, we can try to get the first element in card linked hash set. And in this case, we have to write linked hash set collection dot iterator dot next. And we don't have like the same approach between all of these collections, but let's do another one example. Let's get like the last element from all of them. And I don't want to spend your time and to read all of these texts. However, as you can see, we have like even worse approach for that, and we have to remember a lot of different constructions in case if we want to get first, last, next, and work with them. And now they are synchronized. They are synchronized between each other, and they are synchronized under this synchronized collection, for example. This synchronized collection is an interface, and this interface, let me maybe click, yeah. Let me show you in this way. This interface has under the hood only some methods like add first, add last, get first, get last, remove first, remove last, and reserved. Let's come back and just look at that. That's great because for now you don't need to keep all of these constructions inside of your head. Just what do you need? You just need to work with sequenced collection, and you don't need to understand what kind of collection you okay, you have to understand what kind of collection do you use, because different data structures, using of different data structures for resolving different kind of tasks, it's important, and remember that. But when you choose some certain data structure, for example, you can choose array dequeue. After it, directly after it, you don't need to remember all of these special implementations for this array dequeue. You can just use get first, get last, and the same methods are available for all of these types, or for all of these implementations. Whew, okay. And actually, guys, we have only 1, 2, 3 slides, because within this one, I don't want to show you any kind of examples, because this is new ZGC garbage collector generator, right? And implementation. That's also right. That goes to and follows after G1, our garbage collector. And within this, that garbage collector, that garbage collector, right? And this that garbage collector implements new feature. Okay, the third time, new feature, where within this garbage collector, all of the data within the memory will be split into two places, like younger generation and older generation. The first time when you can tell me, hey Nick, why? And I read about Java memory model. We had before like young generation piece of heap, like old generation survival with some different pieces inside of it. Why do we split for now into two places? And yes, it is new feature that was released only for that garbage collector, because before this garbage collector, and this is pretty powerful garbage collector, which can work with huge heaps, and it can clean your heap within milliseconds, within nanoseconds, and it can work with like terabyte of data, not terabyte, I'm not sure about terabyte, but about 100 gigabytes for sure. It can clean it within super short period of time. And for now, this all of this heap is split before young generation and old generation. And young generation, as you remember from Java memory module, into young generation place of your heap will be placed new objects, and they will be cleaned faster and like more frequently in comparison with old generation, just to keep and save our computation time. And that's it about JEPs. For now, we will be talking about new features, new methods that were implemented within new version of Java. And as I mentioned before, for now we have new sequenced collections, new sequence set, and so on and so forth. And for me, it's within and why while I was preparing this presentation for you guys, for me it was a discovery that before we had new set from map method, and this method was introduced for Java 1.6. However, now we have new sequenced set from map. Why do we need to use this method? I was thinking before, and why it can be useful for us to use new set from map method. Let's see that. And this example I want to show you. I hope that for now we have a lot of questions. I hope. I will try maybe to read them pretty quickly. But guys, if you can help me with it, maybe when I ask to put your questions, could you please maybe copy paste them for not to spend some time and to scroll down through whole of the chat. Let's move to our readme.md once again. New methods, and yep, the last branch, but not the last cup of soft drinks. Okay, the first method, have no sense Java 17 test. What do we have here? Oh yeah, what do we have here? We have here new set, and this set will be created from collections, new set from map. And here as an implementation of this set, we will have hash map. And actually it doesn't make sense, because set and this method will create hash set in our case, and instead of it we can create we just can create directly our hash set. That's why it have no sense. Okay, doubtful, doubtful, but okay. Okay, I hope that you remember about and you know about this pull request on GitHub about Oleg Tinkov. Сомнительно, но окей. Sorry, this is like synchronized translation. What can we have here? And why this method can be useful for us? Because we have a lot of different implementations in case of our maps. We can have like hash map, linked hash map, or no, I don't remember. I don't remember, but one of the implementations that we don't have in case of set, because set actually uses under the hood like different implementations of map. But one of the implementation that set doesn't have is weak hash map. And to have this ability to wrap this map implementation and to get set from it, this is like the using of a new set from map method. And I saw that this method can be used as well in case of we have some map, and this map has a lot of elements inside of it, and we can create like on the runtime from a set of these elements like another set, and we can transform this map into set data structure. However, as you can see here, we can't do that because when we create this map, when we write down and fill this map with 4 elements, for example, it returns us illegal argument exception. That's why this method like isn't useful in case if we want to wrap some map data structure which already has elements inside of it. Okay, and let me show you this example about a sequenced set with a strict number of elements. And actually under this method, you will see this new method, new sequenced set from map. Why it can be useful for us? Because as you remember, sequenced set or other sequenced collection, they have some strict order. And with using this strict order, what can we do? We can create linked hash map, and we can override this method, remove eldest entry. And with this method, we can, for example, set some restriction for 5 elements. And what will we have in this case? In this case, we will have, let me maybe show you, and maybe let me run this example. Nothing on the logs. Oh yeah, yes, because I have nothing in my logs. However, here I have this assert equals, just to check that I have what kind of element do I have as a first element and as a last element. And as you can see, I try to put there 16 different elements, but this set will consist of only 5 of them. And only 5 of them, and the last 5 will be added into it. And another new one will be added. The oldest one will be dropped from this like queue, like real queue. Last in, last leaf of if, you know. Okay, let's do it together. Last in, last out. Yes, maybe this kind of queue, but check it. In case if I'm wrong, please type about that on the comments right here, or if in case if you watch it as a record, as a recording, please you have an ability to think about that, to Google it, and write down the right answer under this video. Okay, what do we have more? And these 1, 2, 3 methods that's a new wrappers, and as you may know, we have like the same wrappers to create unmodifiable collection from typical collection, and we can use and we can receive array list, and we can wrap this array list with unmodifiable collection method, and this array list will be immutable. And for sequenced collections, we have like the same stuff. I don't want to show you that because it's pretty obvious. Another set of methods that can be that you can use for string and for string builder, index of for string, index of with some restrictions from what kind of index do we want to start this searching, and with end index, also pretty obvious additional method and additional parameters for this method because we had before index of. However, this method split with delimiters, it can be useful for you because before we had the same, however, just split, and we can put down some kind of rule, how are we going to split it, and when it is split before, look here, string block, here we have, and we want to split the string block with using delimiters. If I run this code, yes, as you can see, I've created a string array, and within this string array, for split with with this split with delimiters, I used as input variables this rule. What do I want to split, and limit how many parts do I need to use in my result. However, here, as you can see, like just pretty same method, split and split with delimiters. However, here we have different results for them. For using split, we have, and it is expected, we have 3 parts. For split with delimiters, we have 5 parts. And on the console, I compared these results between them, and yes, as you can see here, this is the result for split, because we don't have these special symbols that was used as a rule for splitting. Here we have it. That's why we have different results. We have 3 for this one, and we have 5 for another one. And what else? Repeat for string builder also. Before we can implement this repeating rule, and we can implement them with using, for example, Java Stream API. And between line number 40 and between line number 56, you could see 2 examples, and result of these examples is the same. However, like 2 different approaches, and in case of here we have to and where we try to remember this Java Stream API different constructions to make this result. Instead of it, here we just can write down Spring Builder. Please repeat this piece here 3 times, and summarize it with another piece. And on the line 55, we have this assert that well, let's maybe make sure that it works. Yes, it works, and this test works as well. Phew, it works. And one additional method, as I like memes, and I like emojis, and within this presentation you could see that, and Java also for now likes it. And within Java we have for now we have an ability to check if this symbol is emoji or not. And for all of these emojis, this test will return true, and only for one of them, because it's not emoji, it returns false. And the last one, I hope that this is the last one. Yes, this is the last one. The last one method that I wanted to show you, clamp, but here I don't know what I can tell you. It's pretty easy method. This is the implementation of this method. But before, if we had to write down this method and this implementation somewhere and use it within our code to have this kind of clamps for values where we can put minimum value, we can put maximum value, and check in case of your number, if your input number inside of it, everything is great. In case of this, your input value less than minimum value, it will be equals minimum, and vice versa. In case if it is greater than maximum, it will be equal to maximum. And guys, whew, it was like it was pretty complicated exercise, but I want to tell you that that's it. For now, this is the part for your questions. That's why let me stop sharing my screen. Let me open Workplace. I can see here Workplace, and I hope that I will see your questions here. Just can see some of them, not all of them. Okay. Okay, Konstantin Chumak. One more thing about records. You can declare it in a method. Sometimes it might be useful. And this is, let's come back here just to look at it. And this is the example. Okay, what do we have here? We have public void record person. Create instance of record. Oh, sorry, maybe I don't get it. But let me maybe read it one more time, once again. You can declare it. Oh, in a method. Okay, yeah, inside of method, and yes, you can inject your records inside of your code, because in case if you have like pretty and yeah, thank you, Konstantin, for this mentioning. Yes, because when you have like a pretty easy data structure that you want to declare and that you want to directly use, you can declare it directly within your method. That's correct. Thank you, Konstantin. I would add and compare fork join between fixed thread pool and virtual threads. That's great. That's great because actually, as you could see here, this and like within these 3 slides, this implementation of virtual threads, actually the same mechanism is used for fork join pools. And I don't remember, or even I don't know if Java developers just get it as it is, or it was used like this paradigm was used that is used for fork join pool as well, because because in case of fork join pool we have the same rules that I showed you before. In case of we have no any tasks for thread, they will be stolen. In case of we don't have and in case of we have some complicated job for our threads, will be created one additional thread, and we will get it from operation system. The same mechanism is relevant for fork join pool and for virtual threads as well. That's why, in case of this comparison, I would say that fork join pool mechanism equals to virtual threads. That's a great question. Okay, dokie, guys. As I can see, that's it about questions, or I don't see any others. If you have any, please add them right now. Okay, in this case, let me show you the latest, I would say, the latest slides. First of all, you can find me there in case if you watch this recording, or in case if you don't have an ability to type me on the chat right now, right here, any questions, but you have them or you will have them after like rewatching it again and again. Please find me and you can text me your questions. And feel free to do that. I'm open for it. And another one slide, as I proposed to you, as I promised you, you can find all of the examples on the GitHub. And in case if you scan this QR code, you will find all of the examples. Moreover, you will find this presentation on the root of this GitHub repository, and please do it. And at the end of this meeting, once again, I started from the information that this is only first one meetup, and we will have more and more. Please stay tuned, and thank you very much, guys. I know that it was so long time, and for me as well, it's a record to have meeting for more than 1.5 hour. Thank you for this record that you were with me, and I hope that you for now know more than you know. I don't know the second form of no, but thank you very much. I will know it. I will know it after this meeting, and stay connected. Thank you. Bye-bye.